In an experiment to determine whether light had a wave nature, we have the Young's double slit experiment. And here we have two slits in a board or a view screen. And if we have light coming through in the direction towards the slits here, if we think of light as a particle, then we would think that, well, some of these particles would go through the slits and others would be bounced back away. And if it's a particle, then we would expect to see two lines on the other side. But what was found was something quite different. Here we have the light coming in to the two slits, and we weren't getting two slits, but we were getting these bands, getting a nice heavy center band in between these two slits, and then we had bands above and below that main slit. And the surprising part was that this main one was in between these two slits. So what would cause this to happen? Well, if we take a look at Huygens Principle, we can see that as the rays of light go through, if light exists as a wave, you get these wave fronts that are traveling along. And this looks like chapter 15, where we have interference of constructive and destructive interference. And so where you have the lines crossed, that's constructive interference. That's where the bright spot in the center came from. And then as you go, you would have other spots or lines that would appear because of constructive interference, and you'd have places where there was no light or destructive interference. So Young's double slit experiment proved that light can exist as a particle, but also exist as a wave.